Hello, today we're going to talk about multi-unit dimensional analysis. So let's start with an example using apples. So let's say we have one case of apples, large amount of apples, and it costs $18.50. What is the cost per dozen if that case contains 12 dozen apples? So this is a simpler example to help you kind of understand the idea of using these multi-unit conversions. So let's start it out like this. If I have one case contains 12 dozen apples. And whenever you have these multi-unit dimensional analysis problems, you'll always have a different unit on the top and the bottom of a fraction. We also know that one case costs $18.50. I want to take case this time and put the one case on the bottom. One case is $18.50. That way, when you multiply across, because you always multiply across when you're doing fractions, you'll get cases times dollars on the top and dozen apples times cases on the bottom. Well, case then will cancel because you have one on the top and one on the bottom. And so when you multiply and divide, you'll get $18.50 divided by 12. And when you simplify that, you get $1.54 per dozen apples. And so I know that I have dollars on the top and a dozen apples on the bottom because I did not cancel those units out. So that's the dollars per dozen. So whenever you see this per, it means that you're dividing. So cost in dollars over dozen of apples on the bottom. Okay, so let's do an example with miles per gallon. So let's say a car travels 310 miles on 8.5 gallons of gas. How many miles is the car able to travel when 50 gallons of gas are used? So this one has effectively two things going on. We have miles and gallons in this one scenario, and just gallons for this other scenario. It's easier if you have more than one situation. Easier if you start the one without only one unit. I'm going to abbreviate gallons as GAL. I have 50 gallons of gas that we're starting with. And I know that I can go 310 miles on 8.5 gallons. So I want to put that 8.5 gallons on the bottom and the 310 miles on the top. From there, you can cancel out gallons. So that's why I chose to put this number on the bottom and this number on the top. And then you'll multiply across 50 times 310 divided by 8.5. And you'll get the total number of miles was 1820. And I rounded to 3 significant digits here because the gallons were measured in 3 significant figures. So those 3 sig figs in our final answer. Okay, so here's more of a chemistry example using density. The density of aluminum is 2.7 grams per milliliter. What is the volume in cubic centimeters of a 3.5 kilogram block of aluminum? So we're going to use multiple conversion factors here. And again, I have my multi-unit measurement there, grams and milliliters, grams per milliliter, right? And then just 3.5 kilograms. So it's much easier if you start with the single unit, 3.5 kilograms. Now, I have 3.5 kilograms. In density here, I've got grams. So I want to change kilograms to grams first. In 1 kilogram, there are 1,000 grams, like that. And now that I have grams, I can use my density. I want to use density on the bottom here, the 2.7 grams for every 1 milliliter. That's what that division means, really. That's how many grams are in 1 milliliter of the substance. So I've got grams on the bottom, now the grams cancel. Now, finally, that's milliliters, but the question wants us to find it in cubic centimeters. 1 milliliter is the same thing as saying 1 cubic centimeter. I'm showing it here so you can see the conversion factor, but it is the same unit. It's just one is in SI units, the other one's not. So the milliliters can cancel out, and I'm left with cubic centimeters. So you know you're done because you have your final unit that you're looking for not canceled out. So you would solve this by doing 3.5 times 1,000 divided by 2.7, and the ones don't really affect anything. And here we get 1,300 cubic centimeters. And I use 2 sig figs because I have 2 sig figs in our problem. And so that's how you can use these multi-unit in any kind of dimensional analysis conversion problems.